Okay, so what we're going to do here is start to fix a couple problems since we've got most of the logic laid out here. What I'm going to do is go back here and we're going to delete everything, I think, except for grid number 5. So I'm just going to down here click on manual update so that this doesn't refresh yet, and just kind of delete everything here that I don't need. And I can put this back to auto update. Just wait a quick second. There we go. And I'm just going to put this back down to one iteration here. Going back here, let's turn off our randomness. And I'm just going to keep our scale here set at 1. Okay, so one thing that would be good before we start adding randomness in here would be to make sure that we are centered exactly on our primitive. So currently we're offset here, and it can make it a little bit strange. And you see this when we are starting to work with stuff that isn't actually a square proportion. So we're going to add something that centers this right on the primitive before we do any kind of randomization to it. So let's go right ahead. Just go back in here. So what we want to do is we want to find out what is the bounding box of this object. Basically, what's the scale in the x dimension and then the scale of the y dimension. Find out what the difference is between that and 1. So if you remember, each of these primitives go from 0 to 1. And we've normalized our geometry. So if our geometry, the longest side here is going to be a length of 1, and then the shorter sides will be something else that tries to keep it proportionate. So whatever the difference is between the shorter side and 1, we need to divide that by half and then shift it over. So it's going to be fairly simple. We're just going to press tab and put down a bounding box here. If we want to grab our first input, just bring it right in here. And now what we will do is find the minimum of our x, y, and z. Actually, I think we want the max, not the minimum. There we go. So we want to find the maximum value of our x and our y and our z here. And we want to know what the difference is, because minimum should generally be 0 for these. So what's the maximum value? And then we want to take the number 1 and subtract that value from there. So there's a VOP here that already does that for us, and that's called a complement. And you can see the icon here says 1 minus x. So I'm just going to do that for the x, and then again for the y. And now we need to make this back into a vector component. So pressing tab and just typing float to vector. And we're just going to wire x right into here and y right into there. And now we need to divide this by 2. And we're not going to add anything to z here. So we can press divide and just grab a divide by a constant. We'll just put 2 right here. Now we want to offset our initial position by that value. So I'm just going to grab our initial position here, P, and add to this outcome. So putting down an add, I'm just going to wire this right into position, and then this right here. And now instead of feeding our position, into our transformation, we will feed our modified position here. And you can see that this has now shifted over to the center. One other thing that might be interesting to add here as well would be the ability for each iteration to change the orientation of this object. So you'll see if I go up here, and now I put this on 2 iterations, I'm going to have to put some kind of randomness in here as well so that we can see. So you see that each one of these iterations here, if for some reason it gets the same object placed on it, it has the same orientation, and that may be what you want or it may not be what you want. So let's just add something in here so that we can randomize the orientation here. And the way I'm going to do this is by swapping the UV coordinates, by swapping U for V. Pretty simple. So what we'll do here is we will put down a switch. So I'm pressing tab and switching. And we could just say if this value is false, we'll just continue with our UVs here. And then if it's going to be true, then we'll swap. So we'll do something similar where we break the vector components out. So I'm going to say vector to float. And then we'll say float to vector. And make sure now that we're swapping X and Y. We can just plug Z back in here. And that will go into the second input. I'm just going to wire this into our UV. And let's just test that that's working first. So if I dial 1, we should see that we do a 90-degree switch. So we're getting this random seed here. We'll just use the same random seed. And what we'll do is I'm pressing tab and we are comparing that seed. So I'm just using a comparison. So we just wire that into the first input. It's not the actual random seed, it's the value from the random SOP here, or VOP here. And what we want to know is if that's greater than 0.5. So half of them will go one way, half will go the other way. Then we are going to switch. And then we can also put a little control to enable random rotation as well. So why don't we do this? We will as well make a little more room here. And we'll just put down another switch. We will bring in our initial transformation here for the false, and then we will bring in our entire modified setup here as well. Wire that right in. And then we're just going to middle click and promote that parameter. We're going to change the type into a toggle. There we go. And we'll call this enable random rotation. Randomized rotation. Let's go up a level here. Cool, that seems to be working just fine. I think one thing that we can do as well while we're here is maybe just add some other value here for the main iteration seed. Because I do notice that we tend to get some stuff that looks like it stacks up a little bit. So why don't we try that? Let's just, again, put down a multiply constant. And I'm just going to finger mash again. Maybe that will give us a better random distribution. We can keep playing as well. All right, so while we are here, I think one thing we can do is give us a random z-scale as well. So it's really helpful when we're doing things that have this kind of blocky appearance. We can make each one keep the same size if we want, but just scale differently, which gives a nice look to it, nice variation. So we'll just go all the way down to where we are getting our z-scale here, which is coming in all down here, and we're just going to add a multiplier. So we will, I'm going to take a fit, pressing tab and grabbing a fit range. And again, we're going to grab our random value that's coming in here. And let's see, I believe we're multiplying here. That's great. So we'll continue to multiply. I'm just going to initialize that at 1. Wire that right in. And then promote both of these. So we will just call this min z scale. And I'll call this one max z scale. Let's go up. Let's add an iteration in here. Cool, seems to be working so far. Turn off the colors for a second here, just so that we can start to see some of the complexity that we're building in here. Okay, so this is only one object here that's been copied down here, but you can see starting to add lots and lots of levels of complexity in here. So let's go ahead and save our asset and save the file.